Hello and welcome to Diplomatic Derivatives. In today's episode, in pure mathematics, specifically group theory, we are touching a theorem that is the Lagrange's theorem. Now, what does this theorem say? If G is a finite group and H is a subgroup of G, then the order of H divides the order of G. First, we'll try to understand what the statement itself means, and then we'll move on to the main theorem. So let's see what this is. Now, before moving on directly to the theorem, we will just revise a concept that will be used in the theorem itself, that is about cosets. Now, for the cosets, I've already made one video in which I've explained in detail what cosets are, so make sure you check that video out. The link is in the description box below. Just a quick recap. Coset is basically when given a subgroup of subgroup H, which is the subgroup of G, and an element small letter g, element of G, the left coset of H with respect to G is GH equals to GH such that H element of H. Now, what does this mean? That we have a main group. Let's suppose that's capital G, and this is just an example that I've written over here. It's not obviously a real group. This is just for your understanding. So we have a group G, and these are the elements inside G. Let's suppose we take one element, that's this small letter G. We take that element, and then here we have a subgroup, that's capital H, and it's a subgroup of G, so the elements inside H are obviously definitely present in the main group, right? Now we take this small letter g and we perform the operation of this g with this subgroup from the left. So that becomes the left coset. If we perform the operation from the right, becomes the right coset. And by performing operation on a subgroup, it means that you take one element of g, perform the operation, let's suppose it's multiplication. So you multiply g into this h, then this g into e, then g into f. So you get GH, GE, and GF. This is one of the left cosets. Similarly, you take another element, let's suppose K, and perform the operation on the subgroup H, so it becomes KH. So it becomes KH, KE, and KF. And similarly, performing the same operation with the rest of the elements of capital G with the subgroup H, and you get a number of left cosets. Okay. Now, what are the properties of these cosets? Again, we have already explained this in the main video, so make sure you check that out. All left cosets have the same size as H. So whatever the cosets are, their size is going to be similar to the subgroup. Any two left cosets are either equal or disjoint. So if you talk about two left cosets, they are the right cosets, anything. They would be either equal or disjoint. Here we can say they are clearly disjoint. There are no similar elements. Okay. The set of all left cosets covers the group G. So all the left cosets of H are together, when you make a union of those left cosets, together they will give you the main set G. So together they will have all the elements that are present inside G. Nothing is left out. Okay. These properties are important for Lagrange's theorem. Okay. Now, again, just going back to the main statement of the theorem, let G be a finite group and H be a subgroup of G, then the order of H divides the order of G. So H is going to divide G into a specific number of subgroups, okay? As a concept, you can understand it in this manner. Think of G as a large group of soldiers and H as squads of equal size. So these squads are coming out of what? They are coming out of the main group of soldiers, okay, and the squads are of equal sizes. Lagrange's theorem says that you can divide the whole group into distinct equal sized squads and no member is left out or repeated. So nothing is left out, nothing is repeated. All the soldiers are used in equal sized squads, okay, and when you make a union of those squads, they will make the entire group G. All those squads have equal number of elements, okay, and nothing is left out and nothing is repeated, okay. So everything is divided properly. There is no repetition and there is no leaving out of any element, okay. This is what Lagrange's theorem says. So they will exactly divide each other. H is going to divide it G completely, okay. We see how we prove it. First of all, step 1, partition the left group using left cosets. Let G be a finite group and H a subgroup of G. So all the left cosets of H and G are what? First left coset will be small letter g, which is first element of the, we take g1 as the first element of g, make a coset with it, so it will be g1h. Second one will be the second element of g, that will be g2, so the coset will be g2h. Similarly, so on till gkh. So gkh is the last element of g. Make a coset of it from the left, so it will be gkh. Okay, so g1, g2 till gk are the elements of g. All right. These cosets are disjoint. So basically what we are doing is we are making a union of these cosets, and together all of these cosets after a union will give us the main group G. Okay, these cosets are disjoint. The property that all the left cosets are disjoint or same. So we are saying that these are disjoint. There is no overlap. Okay. Each coset, make sure you remember the story of the soldiers and the Scots. So that's exactly what's happening here. Okay, each coset has exactly order of h elements. So again, the same thing, that the size of the coset is similar to the size of the subgroup. Together they cover the whole group. That is what we saw here from the union of those cosets. Okay, so we have partitioned G into k pieces, each of size h. Okay, so G is divided into k number of pieces, and the size of each coset is the order of h. All right. Next, if there are k distinct cosets, so we have divided G into how many number of cosets? Number of cosets is k, and each coset has, what is the order of each coset? H, the order of h, right? So what will be the total? So it's a basic understanding that if the number of cosets is k and their size is h, so how many total cosets will be there? That is the order of G. So total will be k, number of cosets k into the order of h will give us the order of G. This is what we get from the basic understanding, that order of G will be equal to k dot order of h. Okay, because the total number of cosets is k and size of each coset is the order of h. Together is the order of G. This implies that order of h divides order of G. How? That is, if you take the order of h on this side, here it is multiplied, right? So over there it will be divided. So you will have order of G divided by the order of h. Okay. So k is equal to order of G divided by order of h, which implies that order of h divides the order of G. This symbol over here means divides. Okay, it's not slash. It's a straight line. Straight line means it divides the order. Okay, so for example, this is what basically Lagrange's theorem says. Okay, now what if you want an example that it will make it much more clear. Okay, we will see an example in the next page also. I will just make you understand it slightly here. Let's suppose the order of G is, this is the basic statement, right? K is equal to order of G divided by order of h. Let's suppose the order of G is 3, or make it 4. Let's suppose the order of G is 4 and the order of h is 2, which is a subgroup, right? So order of h will be 2. So 4 is divided by 2, right? Which will give us the value of k as 2. Okay, so basically h is completely dividing the order of G. Or if you can have the order of G as 6 and order of h as 3. So they completely divide. 3 completely divides 6 equally. Completely is equally divides 6, right? There has to be this equal division. Or we can say we have 8 by 2. So 8 is equally divided by 2 how many times? 4 times. So this is what Lagrange's theorem is. That there is an equal division by the subgroup to the group. Okay? We'll take an example as well. So let G is equal to Z12. Z is integers and 12 is the number of elements. Okay, so it is the number of elements as in till where it goes. So it starts from 0 till 11. So that makes 12 number of elements is 12. Okay, and H is generated by 4. So 4 is one of the elements inside Z12, right? And it is generated by 4. So that will be 0, 4 and 8. This is one of the subgroups. So this is the main group and this is the subgroup. Then the cosets are. Now Cosets will be made from what? From the main group, right? So we take, let's suppose the first element we take is 0. The operation is addition. So it will be 0 added from the left if it's left cosets, okay? So 0 plus 0, we get 0. Then 0 plus 4 gives us 4. 0 plus 8 gives us 8. Then take the next element. This is the first coset, okay? Then take the next element 1. 1 plus 0, 1. 1 plus 4, 5. 1 plus 8, 9. Okay, now if you look here, you have 0, 4, 8 inside the main group. You have 1, 5, 9 inside the main group. Okay, so these elements exist inside the main group. This main group is being divided. Okay, then we have 2. 2 plus 0, 2. 2 plus 4, 6. 2 plus 8, 10. Again, the elements exist here and these are being divided here. These elements do not exist here. These elements do not exist here. They're all disjoint. Then again 3. 3 plus 0, 3. 3 plus 4, 7. And 3 plus 8, 11. Again, these elements do not exist anywhere else in the cosets. They are coming from the main group. Now you cannot go any further. Let's suppose you take 4 from here. You take 4 plus 0, 4. And 4 plus 4, 8. And then 4 plus 8, 12. 12 does not exist in this group. Therefore, these are the only cosets that can be formed. You cannot form another coset. These are the only ones because 4 plus h won't exist. Since the element 12 that will come in that 4 plus h coset does not exist in the main group. Therefore, these are the only 4 left cosets of Z12. Okay, that is 0 plus h, 1 plus h, 2 plus h and 3 plus h. Alright, now these 4 cosets partition Z12 into sets of 3 elements. That is 12, that is the order of the main group coming from the Lagrange's theorem. That is order of G is equal to K into order of H, right? So H divides the order of G. We see here, that is, this is proved from this example that 12 is the order of G equal to number of cosets. How many number of cosets do we have? We have the number of cosets are 4. So it becomes 4 into order of H. Order of H is 3. So that is 4 into 3 equals to 12. This is what Lagrange's theorem is proving. If you write it in the division form, that is order of G divides the order of H. Okay. If you're making it like this, so order of G is what? 12 and order of H is 3. So what do you get? You get 4. Alright. That there is an equal distribution of elements. So each coset has 3 elements and number of cosets are 4. So this is a very clear example to explain what the Lagrange's theorem actually proves. Alright. So that's all for this video. Thank you for watching and make sure you understand this concept because this is one of the basic and fundamental theorems in group theory. So that's all for today. I'll see you in the next video. Make sure you like, share and subscribe to my channel. If you have any questions, comment down in the comment box below. And that's all for this video. Thank you. Bye bye.